Okay, we're going to look at sketching trig graphs. So we'll start off with looking at what basic sine graph looks like. So just looking at the unit circle here, just remember that sine is your up and down, and cosine is your left and right. So if we're graphing what happens, so we're going to graph our angle on the x-axis and versus the sine of that angle on the y-axis. So as our angle increases, what's going to happen to sine? Well, sine is the vertical, so sine starts at 0. So sine will start right here at 0. It's going to increase, then it's going to go back to 0, then it's going to decrease and back to 0. And it's going to be back to 0 at 2 pi. Alright, and then it's going to repeat and do exactly the same thing again. So the period, so this is the graph of y equals, y equals sine x. So we'll actually just think of these as xy, like a normal graph. Okay, so y equals sine of x. The period equals 2 pi. That's how long it takes until our graph repeats itself. And during this period, which is one revolution of a circle, we've sort of got these four points on the circle, which are happening at equal intervals. Okay, so we can divide this period into 4 equal parts. Okay, so we've got halfway is pi. Divide it in half, and then divide each of those into halves. Oh, that's 3 pi over 2, and this is pi over 2. Okay, so we divide period, divide it by 4. Alright, now let's have a look. The maximum that sine can ever get to is up here, it's 1. Okay, so 1 is the maximum value that sine can ever have. Okay, so we could draw a little dotted line here. And same at the bottom, 270 degrees or 3 pi over 2, negative 1 is the lowest value that sine can have. Okay, so sine will start in the middle, and then at pi over 2, sine is 1, so it's up here at 1. At pi, which is 180 degrees, we're back to 0, so we can mark this point. And at 3 pi over 2, we're at negative 1, and then we're back at 0. Okay, so this is the general shape, and it's a nice sort of curve, fits in like this. These are not half circles, so they don't come down vertically here. And this, if you were to keep going, this pattern is just going to repeat again and again as you do each lapse, each revolution, each extra revolution of a circle, and even going backward, it's going to repeat. Alright, so that is what the sine graph looks like. Okay, so sine starts in the middle, goes up, back to the middle, down, back to the middle. And if we looked at a cosine graph, y equals cos x. Again, the highest and the lowest it can have is plus and minus 1. And again, it is going to repeat after a full circle. All of these will repeat after a full circle of 2 pi. Okay. So again, we've got a period equals 2 pi. Again, divide your period into 4. Okay, divide period by 4 and mark these points. And here we go, 3 pi over 2. Okay, and if we look at each of these 4 points on the circle, remember cos is the first number in these pairs. So cos starts at 1, it's the left right. Cos starts at 1 up here. Up at 90 degrees, pi over 2, pi is, so cos is 0. And in the next point, we're at -1. Okay, so I'm just going through each of these sections that I divided up to find what the value of cos is. 3 pi over 2, we're back at 0. 2 pi, we're back at 1. So we can sketch our curve something like this. Okay, so this is what you need to have when you're sketching a curve. You need to show the top and the bottom. You need to show the points. We call those key points. Okay, key points of the graph. So where it's at the highest, where it's at the lowest, and where it's in the middle. Alright, so what can happen? That's a basic curve, so we can get we can be asked to sketch something like y equals 5 sine 2 pi x, let's just say 2x plus 3, for example. Okay, so we've changed a few things. Okay, we've got, this is a dilation. This is a vertical dilation. So this stretches it up. This is a horizontal dilation. So this will shrink or expand it horizontally, and this is a vertical shift. Shifts the whole graph up. Alright, so if we're sketching this, we need to start with vertical shift. Actually, I know this one's going to be a bit more this way. Okay, x, y. Okay, the vertical shift is 3. So that means that the middle of our graph is no longer going to be at 0, it's going to be at 3. Okay, so this is our vertical shift. The dilation. This is, we can also call this the amplitude. And this tells us the normal amplitude is, this one has an amplitude of 1. Amplitude equals 1. So it's the distance from the middle of your graph to the top, or the middle to the bottom. Okay, so in this case, our amplitude is 5. So this is our middle. Now our top, our amplitude is 5. So our top now is going to be 8. 3 plus 5 is 8. Our bottom, just sketching our guidelines here. Our bottom will be -2. Alright, so this is a distance of 5 down. Okay, so that's the first thing is we do is a vertical shift. Okay, now, and then we added in let's just stick to calling this the amplitude. That was the second thing we did. So we did the 3, we did the 5, now we've got the 2. Okay, now the 2. So the horizontal dilation. Horizontal dilation. Okay, this one, our period is going to change. And we have this formula. Let me write this in general terms here. This is A sine bx plus d. Okay, so what we're looking at is this b. This is a letter we'll always use here. Okay, so the period equals 2 pi divided by b. Just remember that formula. The normal period, normally b is 1. In the first two examples we looked at, we didn't have a number, and we just had sine x, so b was 1. so the period was just 2 pi. If we have a number there, we have to work out the period by dividing it by whatever that number is. So in this case, in our example here, our period b is 2, so the period is 2 pi divided by 2, which is pi. Okay, so we'll mark that on our middle here. We need to mark it on our axes, pi. And we need to divide that into 4. So we've got pi over 2, pi over 4, and 3 pi over 4. So these are our key points. Okay, this is a sine graph, so just going by what we did earlier in our sine graph, it has to have the same basic shape. And if you look here, it starts in the middle of our graph, so the middle of our graph is here. At the first key point, we're at the top, so our first key point, pi over 4, now we're at the top. Our second key point there, we're in the middle. The next one, we're on the bottom. And the next one, we're back in the middle. And then we can sketch. And if it had been a cosine curve, we would have just had to start at our highest point. Okay, let me just add in here lightly what this would have looked like if we'd had a if we were doing a cos curve. 2x plus 3. Okay, this thing, everything's the same, except now we start at the top. And our first key point is in the middle. Next key point is at the bottom, so it's looking like this. Next key point is back in the middle. And the last key point is at the top. Alright, so that is y equals 5 cos 2x plus 3. This is y equals 5 sine 2x plus 3. Done.